This demonstration is done on a server rack installed in an isolated 3-phase 240-volt panel. Phase A contains a small amount of area lighting and has an average current draw of 0.5 amps. Phase B contains mainly storage and has an average current draw of 4.5 amps. Phase C contains a variety of GPU processing and has the highest average current draw of 18 amps. Also depicted here are the ground and neutral wires. We have exaggerated the load imbalance in order to demonstrate the effectiveness of the automatic phase balancing feature of 3DFS technology. In a typical data center, the imbalance is not as substantial as this, but is always present due to the nonlinear nature of server rack power consumption. Please note that the power drawn on each phase from the transformer is identical to the demand on each phase. Now we will discuss the harmful effects and additional costs associated with unbalanced phases in data center environments. Utility companies use historical power consumption data to extrapolate how much power a data center will require at any given moment. To do this, they analyze how much power is drawn on each incoming phase. When the phases are imbalanced, the utility company assumes that the highest peak usage among the phases is the potential usage on all phases. Customers pay for the excess capacity even though it is unused. These charges affect customers differently across energy suppliers, but exist in some form in all of them and can be a substantial percentage of the power bill. Transformers, UPSs, generators, and other electrical network infrastructure underperform, experience wear and tear, and overheat due to the increase in line impedance and reactive power related to unbalanced phases. This results in more frequent repair and replacement of these critical electrical network components and also affects the day-to-day stability of the power network. Neutral wires will carry current when phases are unbalanced, creating safety issues for staff and workers. In addition, neutral line currents increase liability and are notoriously suspected as igniters of fires in homes and businesses. The existing solution for unbalanced loads revolve entirely around manual manipulation of the electrical network and introduce human error at multiple levels. Most data centers attempt to manually balance the server rack loads across the phases by guessing the power consumption on each phase and hoping that it remains steady during operation. Other solutions include load scheduling, which requires cautiously timing loads to turn on or off at specific times in order to avoid large spikes on a particular phase. Also, load shedding, which involves identifying loads that can easily be turned off in order to instantly reduce power demand on a phase. Given the dynamic nature of power consumption in server racks and obvious uptime requirements for data centers, all of these solutions are impractical and fail to achieve ideal load balancing across phases. There are lots of resources from various industry leaders and research institutions describing the negative effects and additional costs related to unbalanced phases. These are a few of them, and we will include the links in the post beneath this video. Now we will show how 3DFS technology is the first commercially available product that automatically balances the loads across the phases, eliminating human error from this process. The power controller analyzes the real-time power demand and immediately optimizes electricity and reports data through our secure user interface. During this process, the load balance across the phases is also monitored and corrected, providing dynamic load balancing at all times. The automatic load balancing feature comes standard with the VectorQ2 unit. The VectorQ2 is installed in parallel in the panel. Before it is turned on, please take note of the current draw before the panel and the current draw on the individual loads. The imbalance is equal throughout the system. When the VectorQ2 is turned on, two things happen. The current being drawn upstream from the panel is immediately drawn with equal balance across all phases, and there is a reduction in the current drawn on each phase at the load level. By automatically balancing the loads across the phases, neutral and ground currents are eliminated, reducing liability and improving safety for equipment and personnel. Peak demand charges and penalties related to unbalanced phases are also eliminated, reducing expenses on monthly power bills. UPSs will have a longer runtime, and generators will evenly deliver greater amounts of peak power, while much less heat will be emitted from the transformers and power equipment. Automatic load balancing is one very important feature that comes with 3DFS technology and assists with zero-waste electrical networks in data centers.